afternoon, wherever you are. So as I mentioned in my last video, today I'm here to share about box plot. Very interesting video I'm going to share with you. Most of the people knows about box plot. Uh, People knows, okay, box plot will share both the mean, median, uh, will also have a pictorial representation of spread, will also highlight what is interquartile range or what is the third quartile, first quartile, all this information being shared by, we can see by box plot. But in this video, other than this, people mostly don't know what is the top point, what is the least or the minimum point in the box plot, and what is the formula to see those top and least point, and also how come these uh, outliers being represent in the box plot, and from where these outliers are coming, and what number will be the outlier. So these are the information which I'm going to share today, and also one good example, how a box plot can show us a pictorial representation and will show whether the different vendors, different shift or different groups are are having the same spread and same median, or is there any difference between these vendors or shift? So I'll explain you all these informations through a example. Okay, so you can see this is an example of delivery time for four vendors, which you can see I mentioned here: number one, number two, number three, and number four. So assume there are four vendors, and it's a delivery time information. They are delivering some particular products to some of the company, and they have collected the delivery time information, and on the basis of this they want to see which vendor is working good or delivering the material in a better time or in a good time compared to the others. So this is their delivery time information. Okay, so first part of this video I will dedicate to the box plot, and second part I will dedicate to or I will inform you how you can use the box plot information to review those vendors about their spread, means about the delivery time spread, and the median, and you can also see which vendor looks good to you and which vendor not. Okay, so first half, let's talk about the box plot. So there is an Excel file. You can also create the box plot in Minitab. So I will share both the things with you. So firstly, how you can create a box plot in the Excel file. So first, please select entire delivery time data here. Okay, and then just go to insert recommended charts and go to all charts, and you will find the box plots here. So you can select this is the box plot, click OK, and you have your box plot here. Let me just paste the box plot on the top, right? Sorry. So this is the box plot which is created by this data you can see here. Now in this box plot there are few interesting things. So first of all, this X talks about the average or the mean of this data, which is of delivery time. So mean is here, I already highlighted, which is 94.7, and this data also is the 94.7333 something, right? Now you can see there is a line in the center which talks about the median, which is at 94, right? And here is a formula in the median equals to median something of this particular data. You will get 94. So this is 94. Now let's talk about this line. So this is called third quartile, okay, or Q3. So this is the formula of third quartile. How you get it? You just press equals quartile. There are two quartile. One is called quartile excluding, and the bottom one is called quartile including. Now, what is excluding? What is including? There is also an interesting video which I'm going to prepare after this video, so you can go and understand that what is the meaning of excluding and including. For box plot, we will go with the excluding part or excluding quartile. So I'm selecting excluding quartile. I'm selecting this entire array or entire data, and then it will ask whether you want to check the first quartile, second quartile or third quartile. So third quartile is nothing but 75th percent. Second quartile is the 50th percent or also called median, and first quartile, which is the 25th percentile. So I want to see third quartile, right? So I will press 3 and then I will close the bracket and enter. So when you do this, you will have your 98, which is here on the box plot as well, right? So this is called third quartile. You can go to the first quartile, same formula, I just changed one here because one is for the first quartile. So first quartile is nothing but the 25th percent of the data. So this is your 25th percentile of this particular data, right? So this is called 91. I'm also creating a video, as I mentioned, on the quartile part. What is first quartile? What exactly is third quartile? What exactly is second quartile? You can go and check that video. That's a very interesting video on quartile. Okay, and this is the second quartile. As I said, this is equals to median. So median is this, and also the second quartile is this. Any data, whatever you have, the second quartile will always equals to median. Okay, now there is another interesting thing which is called interquartile range, IQR. The formula is very simple, the third quartile and the second quartile. So here you can see the third quartile is 98 and the first quartile is 91. So the difference between this is 98 minus 91 is 7. So this entire blue color range is called interquartile range, which is equals to 7. Correct? This is pretty simple. Most of the people know about it. Now let's go to the interesting part. You have a top data which is called top point or highest point of this box plot, and you have a bottom point which is called minimum or the least point. Now how to get this number? So formula for this is this, which is called third quartile Q3 plus 1.5 multiplied by IQR, which is interquartile range. So if you put this formula in place, you will get 108.5 as a top point for this data. And the least point is the Q1, which is the first quartile, minus 1.5 IQR, which you will get this number. Believe me, most of the people also know about this formula. The interesting part is, if you see this box plot, the highest point is 100, but our formula is showing 108. Why it is 100? And the lowest point, according to my formula, it is 80, but the lowest point here is 90. You know the reason? The reason is this. In this entire data, the maximum point is 100. It is not 108. So that's why 100 is definitely coming before 108. So that is why this is the highest point. Similarly, the minimum point of this particular data is 90. Even my calculation is showing 80.5, but 80.5, the data point itself is not there in this data, right? So that's why the minimum value here is 90. Correct? Now let's understand this. If I convert, or if I change, let's say, one data point, I know my highest data point or highest top point is maximum up to 108. Let me convert this to 105. I converted this. You can see the box plot change, but still it is showing the highest point at 105, not 108, because 108 is the top point. Okay, now let me convert this to 108. You can see it's converted into 108, but this is the highest point. If I change this data point to 109, assume, what will happen? See, you are getting one outlier. So this is an outlier because as per the calculation, as per the formula, this data point is away or is even beyond this 108.5. So if it is beyond 108.5, means it becomes outlier. So if any point which is under this, if that is the highest point, will become the maximum point. But if any point goes beyond this number, will become the outlier. Assume I change this to 102 again. So you can see this is falling under the box plot. There is no outlier. Why outlier is not there? Because this is your top point. Anything beyond this point goes beyond, like 109, 110. Let me change this to 120. Assume. You can see this is outlier. Let me put two data points as 110 or 110 and 120. You can see there are two outliers now. So that's how you are creating outlier on the basis of top point. Okay, let me convert this again into some number, let's say 90. Okay, and your box plot is here without any outliers. Now let's talk about the least point. Now, according to the minimum data point is 90, right? If I change this number to 85, still you don't have any outlier, but your minimum data point changed to 85, right? But my calculation is showing 80. If I put 80 here, see, 80 is less than 80.5. You will have a outlier. If I keep this 80.6, see, there is no outlier. There is no outlier because the least point is 80. If I put 70, you have a outlier. Let me put this 75. Now we have two outliers, right? So that's how you can create outliers in your data point. Let me just reverse this, and let me just reverse this as well and make it 90 as you. So now you have a box plot, and here you are creating the outlier. Now I think you're very clear on the top point, bottom point, and also how the outliers are coming in the data point, right? Okay, now let me show you. Now let me show you in the mini tab how it works. Okay, let me go to the mini tab very quickly. This is the same data which I shown you just now for vendors and the delivery time, right? So how you can create a box plot. So let me show you a box plot, or how you can create a box plot in mini tab. Just go to graph, and here is your box plot. Simple. Click simple box plot and click OK, and you have to select the delivery time here, right? And click in the multiple graph if you have selected anything, or in the data options, no, data views. Okay, you want to select interquartile range, median confidence, median. Okay, perfect. When you click OK, you will have this your box plot. So same way, this box plot also not showing any outlier, right? Let me just change this data to 120. Okay, and let me just close this and press Control E. You will back to your last window. Click OK. When you click OK, you can see there is outlier, right? So the same thing which you did in the Excel file, it's here in front of you. And okay, let me show you one more thing. If this is 108, assume, and press Control E, click OK. See, you don't have any outlier. Why? Because the highest point was 108.5. So after that only your outlier will start. But whenever you are changing this data point, definitely your median position will shift, because median is coming, or median, or sorry, mean position will shift here and there, because mean is nothing but the sum of all the data points divided by the number of the data points. So mean position is depending upon the outliers as well, but median will not shift, because median is actually removing your outlier, will not considering your outlier if it is one or two. If it is so many, or you have a huge spread, maybe in that case your median will also intact. Now that was the first part of my video. Let's go to the next part. As I said, you have now four vendors, right? And you want to compare which vendor you should go ahead, or which vendor is working good compared to others, or which top three or top two you can select out of these four vendors to work for your future deliveries. Okay, now how you can do it, you just, let me show you one way first. So you can go to graph again, select the box plot, and this time you have to select the multiple wise, because you have multiple vendors. Okay, and then click OK. You have vendors, sorry, instead of graph you have to put delivery time here, and then in the multiple graphs you have to select vendors. Okay, and when you click OK, you will have the box plot. But if you see here, you have the box plot of number 1, number 2, number 3, and number 4 vendor, right? So this is how you are getting, and it is also showing the outliers of number 1, for number 2, number 3, number 4. But it is sometimes not very easy to understand, because these box plot are not parallelly aligned. it is vertically aligned and you are comparing with 1 and 2, 3 and 4 separately. So the simple way for this, let me show you other way how you can do it. So just go to stack, go to ANOVA as we did in my previous slide or previous video, sorry. Click one way, and here in the response area, you select your, one second, let me delete this. You select your delivery time. In the factors, you select your vendors. And here in the graphs, you have to select the box plot. Okay, don't forget that, otherwise it will not appear. And click OK. When you click OK, you will have two graphs. One is for residuals, which we have covered in my previous video, and this box plot. Let me increase the size. Now you have four vendors, and here you have entire data. Now for vendor number one, this is now you have to predict. So most of these vendors are delivering, means the average is somewhere close to 95, no doubt about it. But number one has more outliers, correct? So sometimes it's delivered very early, and sometimes it's also delivering very late. Number three is also very good, but the mean is less than number two, and the spread is also very high. Spread means your quartiles Q1 and Q3 is also spread from 90 to, let's say, 100, because because of this spread, maybe we should not consider it. So in this way, I will go with the number two, because the spread is less. Most of the time he is delivering somewhere close to 97 delivery time, because delivery time means it less is better actually. So but it is more consistent as well. So in that case, if less is better, then I think better we go with the number four, who is very good. And after that, maybe number three, because number four and number three average is good, but in case of three, you have more spread. So in that way, we have to communicate with number three vendor whether he can do something in their areas and improve the variations that he has in their data. So this is how you can predict, or you can discuss, or you can check in the box plot. But again, box plot is just a pictorial representation to tell you, okay, what is the mean, median, and what is the spread of the data. It is not a tool to conclude everything. You have ANOVA and you have many other hypothesis testing to check whether there is a difference between these vendors statistically or not, and then you should conclude your whatever the conclusion you want to do with this data. Okay, so I hope you like this video, and as I said, in my next video I will come up with very interesting thing which is called quartile range, and quartiles, how you can calculate it, what is the difference